Hello class. In this video, I'm gonna go over the concepts of pointers and in what situation you need to use pointer or the advantage of using pointers. Okay, so let's go ahead and get started. I'm gonna show you my slides and then later on we will go look at the code and compile and run the code. Okay, so this is the first slide. What is a pointer? So basically, a pointer contains the memory address of a variable, and the variable will contain the data. So the pointer contains the address of another variable, and that variable contains the data. So if you look at the declaration and the block diagram here, let's say I have an integer variable called my var, and I assign the value of 99 to my var. So the data is the integer 99, and that value is stored in the variable my var. And then I declare another pointer variable called my var pointer. And you notice that the way I declare this variable is I say integer or int, and then asterisk before the variable name. And I say I assign by using equal sign, and I'm using an ampersand in front of a variable name. So the ampersand is called the address of operator. And let's assume that when my program runs, the variable my var occupy memory address 50,000. So when I assign the address of my var to my var pointer or my var PTR, then the content of my var PTR is 50,000. And let's take a look at how we declare the pointers and how we use it. But for now, this is a very high level overview of what it is. All right, so pointer declaration. How do you declare a pointer? You declare the pointer by specify the data type, and follow, you can have a space and then follow by an asterisk and then a variable name. So variable name is variable name goes with the same rule, utilize the same rule as your regular variable. So it means the variable pointer variable have to start with um, a letter, uppercase or lowercase letter, or underscore, and then followed by digits and letters, or we call alphanumeric. And when you see an asterisk in the declaration, it is not an operator, because so far, what you see so far is an asterisk is used in the multiplication expression. So it is a multiplication operator. But when you use it in a declaration statement, it indicates that the variable is a pointer variable. And you can either um, put the asterisk right after the data type and followed by space like this, and then the variable name. Or you can also specify the data type followed by space, and then the asterisk appear right before variable name. So those are the two types style of declaring pointers, and either one is okay. But I get used to the way I declare the variable, the asterisk, right in front of variable name for pointer for the when I declare a pointer. The pointers can be declared to point to objects of any data type. So you can declare pointer variable that contain address of any valid data type in C++. It can be an integer pointer, can be float pointer, can be double pointer, can be character pointers, or can be any class pointer that you define. And usually the pointer should be initialized to a constant called null pointer. This is all lowercase, and actually null pointer has a value of 0, but usually we don't use 0. Instead, we use this word, say null pointer. And it means that if you assign null pointer to a pointer variable, that means it doesn't point to anything. It's contains an invalid address. That's all. All right, so let's move on to the next slide. We talk about the ampersand a little bit in the previous slides. We call the ampersand an address of operator, or address operator for short. And it is a unary operator that obtains the address of its operand. For example, this is how we use it. We say ampersand followed by variable name. What it does is it will say this operator will get the address of my var and put it right here so that you can assign it to this pointer variable. So for example, I just pick memory address 50,000, but it can be a huge number. We don't know what it is until you run your program. So let's say I declare my integer variable int my var, and I assign value of 99. And actually, I should make correction in my slide. It should be 198. Okay, that's the current value. So I assign value of 198 to my var, and my var variable occupy memory address 50,000. Then I declare a my var pointer variable, which contain the address of my var because I assign my var address to this pointer. So it means at inside of my var pointer, it contains the address 50, contain the value 50,000, which is the address of my var. And here's how you can print the value of your data. Let's say I assign my var the value of 99, and if I want to print this data, this value, I have to use an ampersand in front of my variable, and we call this dereference the pointer. That means go to the memory location that is inside of my var pointer and give me the value. So my var contain the memory location 50,000. What this statement does is I say, please go to address 50,000 and dereference it. That means give me the content, and that content is the value 198. So when you do cout dereference a pointer, you are printing the value of the variable that this pointer pointed to. So it looks really confusing, right? Don't worry about it. We will look at several examples, and when you work on your code, you will see depends on the context where the asterisk is placed. It has different meaning, but after you use some example, write some code, it will be clearer. All right, so let's move on to the next slide. We call the asterisk in an expression, we call it the dereference operator. And We also say this is a unary operator. That means it appears in front of one operand versus plus sign or multiplication sign, we call them binary operator. That means it operate on two operands versus the unary operator, it applies to only one operand. So we call the asterisk appear in front of a pointer variable, we call dereference. So if you look at this slide, I already talked about it a little bit. The asterisk appear in front of the pointer variable name. It means use the address that is stored in this pointer variable and get the data from there. And sometimes it also appear in the left-hand side of an assignment statement. That means you are changing the value of the variable that is pointed to by that pointer. So we will look at how that works later. And what are the applications of using pointer? One of the application of using pointer is we're going to use it to achieve pass by reference. So similar to in some of the in previous chapter that we use pass by reference, but we use ampersand to indicate that we are passing a variable to a function by using pass by reference. But in this case, instead of using the ampersand, we are going to use the pointer to achieve the same goal. So I hope you remember what pass by reference means. As a reminder, I want to repeat what you learned. So pass by reference means the function will be able to change the original content of your variable. That's what pass by reference means. So let's take a look at three different ways of passing a variable to a function. The first one is pass by value. Let's say I have a function called myfunc, and the parameter of this function is x. It takes a parameter integer x. If I don't have any special characters in front of variable x, this is called pass by value. It means the function get the value of the variable x, but it will never be able to change the content of the original variable x. That's why we call it pass by value. And you also learn from some of the previous modules, pass by reference with reference arguments. When you specify an ampersand in front of the variable name, in front of the parameter name, like myfunc will take an integer, but instead of just say integer x, we say ampersand x. This is called pass by reference by using reference arguments. So the functions myfunc will be able to change the original content of this variable x that is passed through it via a parameter. The second way to achieve pass by reference is by using pointer arguments. And if you look at the declaration, it looks like this. Myfunc is a function name. So this is the data type of my parameter. That's an int. And instead of say ampersand x, I say asterisk x. That means this function will get the address of an integer variable. And we call it integer. We also call it a pointer. So let's take a look at some of the code later. So these just explain what I just talked about. And let's move on to the next slide. So here is how you can change the original content of your parameter. So let's say I have a function called double value. This function takes an integer pointer and the variable name or the parameter name is my var pointer. So my var pointer contains the address of an integer variable. In order to change the data that is pointed to by my var pointer, I have to use the dereference notation or the asterisk. So this is an assignment statement, right? In the assignment statement, on the left-hand side of the assignment statement usually is your variable name. However, I get the address of an integer variable, but I want to change the original content. I want to change the content of that variable. So I have to use ampersand, not ampersand, the asterisk. I say change or assign the multiply that variable by 2. So I'm making an assignment statement, but actually I'm multiplied by 2 by doing this. So this is similar to this expression that I write on the right-hand side. So instead of writing this long format, I'm shortening it. I write in this format. So if you look at the right-hand side, let's decode this one by one. On the left-hand side of the equal sign is the variable name. The pointer, my var pointer is a variable name, but I'm not changing my var pointer. I'm changing the content of the variable that pointed to by my var pointer, or the address of that value is inside of my var pointer, and I dereference it. And then also on the right-hand side, I say go and get the content of that variable and multiply it by 2 and then assign it to itself. So basically, I just take the variable and I multiply it by 2. And double value want to be able to change the content of the original variable. That's why we want to get the pointer instead of just the data variable. So if I don't have the asterisk, it should look like this, right? If it looks like this, I will not be able to change any variable that is passed to me to the parameter because it become passed by value. So I have to say I'm getting the address of an integer variable and I'm going to change it in this function by using dereference notation. And that's how I do it. And let's move on to the next slide, which will explain multiple meanings of the asterisk. So if you see the asterisk appear in an arithmetic expression like this is a multiplication operator, right? It's obvious, you take the price, you multiply by the quantity, and this is a multiplication operator. If you see the asterisk appear in a declaration statement like this is a declaration of a pointer variable. You declare PTR as a pointer variable which contains the address of an integer. This is the data type that this pointer will point to, or the variable that this pointer will contain the address should be an integer variable. And in this statement, we assign it to null pointer value. That means it doesn't contain a valid address. This is a null pointer is an invalid pointer address. And when you see an assignment statement and you look on the left-hand side, you also see the asterisk appear in front of the variable name. This is not declaration. Declaration have to have the type in front, right? So this is not, obviously, this is not the declaration. And we call this is a indirect indirection operator or dereferencing operator. That means we assign the value of 100 to the variable that this pointer has the address of. And the next slide, let's compare how you achieve pass by reference by using reference variable and by using pointer. On the left-hand side, I'm using reference variable. This is what you learned so far up to this point. I declare a function, change my param 3, and I say my function take an integer variable, and I'm doing pass by reference by saying by using the ampersand, follow the data type. So in my main program, let's say I have an integer variable age and I assign value 10. And I call change my param 3, which is a function I declare up here, and I pass my variable, integer variable age to change my param. In change my param 3, I say this is an integer variable, but it is passed by reference. And then I assign value 99 to the parameter x that I got from my function parameter list. I call another function just for fun. After I return from this function, I go back to the main program. The variable age should be 99 because I changed it in my change param 3. So this is one way to achieve pass by reference by using reference variable. The second method to achieve pass reference but using a pointer variable. And you may wonder, why do we need to do this when we already have this? The answer is back in the old day with C code or C programming language when we didn't have C++, this is how we do it. And later on, C++ add this reference variable. But back in the old day, when C++ didn't exist, this is what you have to do. So my function's name is change my param 2. And I say I'm taking an int star or int asterisk. That means I'm taking a pointer variable, an address of an integer. And in my main program, I declare variable age and I call my change param 2 function, and I'm using ampersand here. So you say, why do we need to use ampersand? Well, the reason is the function change my param. I'm sorry, I should do undo. Okay. So the reason is my change my param said I'm taking a pointer variable. That means I'm taking the address of an integer. How do you get an address of an integer variable? In main, we have an integer variable age, but I told you that the ampersand appear in front of the variable name means you'll get the address of this variable. I'm not passing value 10 to the function, but I'm passing the address of my variable age to the function. And in my function, change my param to, I said, I'm taking a pointer to an integer or an address of an integer variable. And in here, I'm using the asterisk again in an assignment statement. It means dereference the pointer variable and assign it to 22. So what it does is it will change age to 22. That's what it does. Even though it looks complicated and it looks strange, that's all it does. In change param2 does not change the memory location, but it really changed the content of variable age. And that's how you achieve pass by reference when you use a pointer notation. The next slide will show you the common mistake that beginner may make when you are dealing with pointer. In this slide, in this code, let's say I declare my change my param2 take a pointer to an integer or an integer pointer variable, right? In my main, I said I'm gonna call change my param2, and I pass in age, and that is a bug because if you look at the function row type or you look at the function header, it say I'm taking an address of an integer variable. And the function dereference that pointer and assign value 22. So this code is correct because it takes an address of an integer variable and it dereference. That means it will change the original content of that variable. However, the problem is right here. We are not passing the address of an integer variable. We are passing the variable itself. So in order to pass the address of this variable, you have to use ampersand in front of the variable name like this. That will fix the problem. And let's take at the next slide. There is another, well, actually in this slide, if we fix this, then it should look like this. And we got a different problem on this slide. So from here, my function change my param said I'm taking a pointer variable and pointer to integer pointer variable. And in main, then we say, okay, instead of passing age, I'm using ampersand to get the address of age. So I'm doing the right thing in main. However, the problem is in here. Can you tell what the problem is? Change my param said I'm taking an integer pointer variable. And in here, it's a change the pointer to 22. That means it tried to change the content of this pointer to 22, not age to 22. So the problem right here is, sorry, the problem right here is you need to say this. You need to say dereference that pointer and assign the value of 22 to make it correct. That's the problem. So each slice has a different problem. So when dealing with pointer, this is real fairly common mistake. So you have to pay close attention to it. The next slide I'm going to show you is some example of code where you want to print the address of a variable to see that you can really see the address of the variable in memory. So instead of looking at this slide, I'm gonna switch to code to show you how you get the memory addresses of each of these variables. So this is the code you see in the slide, right? And let's go to this code line by line before I run it and show you the output. I'm declaring a lot of different variable types, and I'm printing the memory location of each of these variables. I say the memory location of int age. I have an integer variable age. Notice that I have not assigned any value to any of these variables. I just want to print the memory location of each of these. I don't really have any value because I have not assigned a value to it except for the score array. So the way you get the memory address of any variable is the ampersand. You see the ampersand in front of the variable name. Same thing with GPA. Ampersand Let's skip this line. I will go back and explain it later. Ex the ampersand appear in front of variable name. That's how you get the address, memory location. Int pointer. Right here on line 16, I declare an integer pointer variable and I initialize the integer variable with the address of an array. So when you look at this code, the question is, are we assigning the entire array? The answer is no, we're not assigning the entire array. When you reference an array name, what it means is automatically you get the address, the beginning address of this array, score 100. And the int pointer will get the address, the beginning address of this array, score. So that's what I want to print right here. Line 24, I want to print the address of the score array by using the score as a variable name and using ampersand in front of it. So score is a variable name. I'm using ampersand in front of it. It means give me the address of the score array. Line 25, I say, give me the address of the first element of the score array. You see index 0 mean the first element, right? And I'm using the ampersand in front of it. So I'm getting the address of the first element of the array. And then on this line, I said, I'm going to print the score array memory location, but I'm using a pointer because I assign the beginning address of my array to this pointer. Then I just say I want to print that pointer. I'm not printing the memory address of int pointer. That's what I'm doing right here. So the int pointer itself also occupies some memory storage and it has its own address. But right here, I print the content of int pointer. I'm not printing the address of int pointer. So let's say I'm going to run this code and then you will see all of these numbers in this is memory address when you run your program. Let me rearrange the window a little bit so that you can see both sides, the code and the output. So line 19 says print the address of variable age. That's what you see right here. That's the address. You see the output says 0x. It means these value is hexadecimal number. It's not decimal number. So this is a huge number because this is hexadecimal. We will talk about hexadecimal binary in some future module. And you see the display here, the memory location is always displayed as hex value. So each of these variable has a memory address. Char grade is memory address is this number. However, the trick is there is a problem with if you just say char grade like this, it will print blank. So that's why in order to get this display, I have to do something called casting. And we'll talk about casting in some future lecture. But for now, I need to do this in order to show this, otherwise it will display blank. And you notice that the memory address of the score, I'm using different way to print it, and they all come down to the same memory address. The score array, I'm using ampersand score. You see, this is the address, the beginning address of score array, right? And when I print the address of score array, element 0, index 0. That means the first element of the score array, it has the same address. And that's how it works, right? You have an array of 100 integer, but the first element of the array should be the same as the first byte, or it should have the same address as the array itself, because that's the beginning. And when I use the pointer content, I just say print this pointer. You see that the address is also the same as up here. When I say that's the beginning address of the score array, or that's the first element of the score array, and the value of the pointer is the same. And you notice on line 23, I say, give me the address of the integer pointer or int pointer. It has a different number because this is the memory address of the int pointer. The content of that pointer is the address of the score array, but the pointer itself also occupies some storage in memory, so it has its own address. All right, so that's the output of this program. Let's go back to the slides and then look at a couple more things. Static versus dynamic array. On the left-hand side, I say this is static array. This is how you declare an array so far. That's what you learned so far. You initialize the maximum number of students with a value of 50, and then you say my score array has maximum number of students. So the score array has a maximum of 50 students, and then you can start assigning value to the score array. The second way is called dynamic array. And the way you do it is you declare a variable called max student, and you don't know how many. So you don't want to over allocate an array. You just say, I want to allocate an array that is big enough to accommodate the maximum number of students that my user tell me at runtime. And then you say, I'm going to declare a pointer variable called scores. And this pointer variable score should contain the address of a float variable, floating data type. And then we ask the user, how many students, what's the maximum number of students you want to keep the score of? Then the user tell us the maximum number of students. So based on that information, we say, I'm going to allocate an array that is big enough to accommodate this many students. So I don't need to allocate a maximum size. So most of the time I will waste the space because I will not use them all. So then I can do new. I say allocate some memory address for this array that is big enough to accommodate this many number of students. And the data type of this array is float. So this is similar to what we're doing over here, but the difference is we don't know how many students we have until at runtime. These static array, we have to choose a number. We have to choose the maximum size. So on the right-hand side, we don't have to choose at compile time or when we run our code, but we can allocate an array that is big enough to accommodate the maximum number of students that the user tell us. And after these declarations, you can use this pointer variable like an array, like right here, score index 0, we assign value 89. over here, I can do the same thing because technically my score is a pointer to the beginning of a dynamic array. So technically, I can treat this pointer variable as an array, and I can use index on it. All right, let's move on to the next slide. Where does the memory come from when you do new? So this is the memory layout of a program that is running. So when you compile, build your code, you get an executable, and then you run. This is what the memory layout looks like. So let's take a look at this one block at a time. Um, the segment, the first block down here is called text. This is when the operating system load your program into memory in order to execute your program, in order to run your program. Text means it will load the .exe file. It will load into the memory, and that segment of memory is called text. And the next block of memory is called initialized data. This is where you initialize, you declare some variable and you initialize to some value. And then the next block of memory is used for uninitialized data. That means you declare some variable, but you have not initialized to any value. And then the next block of memory is called the heap. This is where when you this is where your memory is allocated. When you do new, the system grab a piece of memory from the heap. And after it takes that piece of memory, it makes it available for your program to use like this. You assign value, you're using it, and it stay there until you do delete. When you delete that dynamic array, we will talk about delete the array later, then that piece of memory is returned back to the heap. So that's where your memory comes from. The other part of the memory is called the stack. The stack is used when you make the function call. So whenever you make a function call, let's say we go back to this example where in main program, you make a function call, change my program, right? When you make this function call, there is a block of memory called stack frame that is allocated on the stack, and it is used to store the parameters that the main program passed to the functions. And also, if the function happen to declare any local variables, that's where the memory come from. And it will be returned back to the stack when you exit the function. So you don't really control the usage of the stack. The system automatically allocate a piece of memory on the stack and use it when it needs to. And when your function return, it will be returned back to the stack. And you see that the stack is growing from the top down, the heaps growing from the bottom up. If these two memory region collide, you got a problem. But the memory region is big, so it's gonna take a while if you in order for these to collide, but normally they don't, because if you use memory on the heap and you don't need it anymore, then you need to free it. It will be returned back to the heap. So the heap should not grow indefinitely if you free your memory correctly. And the stack is returned to where to the stack frame. When you make a function call, you use a piece of memory on stack, but when you exit the function, it is returned back to the stack. So it becomes free available memory again. All right, that's all I have for this memory, this pointer module. Thanks for listening and watching.